Okay. So next what we will be looking at, see in the last exercise we have used a couple of classes basically which are from the java.io package, right? Okay. So today, yes, we'll get an overview of what is java.io package. Okay, and another thing what we'll be doing today is we'll be looking at a class called file, right, which is used for representing a file in the file system, right? So two things that we'll do today, fine. So let's start. Okay, so let's begin with this input output thing. So what is this java.io package? Okay. Okay. So for any kind of input output, okay, we have this package. Most of the time, yes, basically there are two packages which are to be dealt with. We have this one package called the java.io package, which is there right from the beginning. Okay, so one is the java.io package. So this has been there right from the beginning, and later from Java 4 onwards, okay, there's another related package which is the java.nio. Okay, sorry, it's NIO. So we have the java.io and the java.nio. Of course, java.nio. There are many sub packages to this which are part of the API. Okay. So the base package, yes, the initial package is java.io, but later from Java 4 onwards, and this is from Java 1.4 onwards. Okay. Okay. So from 1.4 onwards, we have the java.nio package. Okay. We'll be mainly be looking at the java.io package. Okay. Okay. So yeah. Now this package, which is the java.io package, is full of 4 kinds of classes basically. Okay. So for doing any input output, right, basically for doing any kind of input output, it is seen in terms of like this. Oh, we want to capture some input from somewhere, right? Okay, so you would have objects. Let me explain that. Okay, so we have basically, even in java.io package, the same kind of a term is used. Okay, we have this thing called streams here also. So we have the IO streams. Let's make a distinction. They're very different from the stream which we have seen earlier. Fine, we had seen the stream as an interface in the java.util.stream package. So this has nothing to do with that. Okay, it's originally there right from the beginning. We call them as IO streams. Okay, so we have the IO stream classes. Okay, fine. These IO stream classes have been categorized. The java.io package is full of the IO stream classes. Okay, most of the classes here are from the Java IO streams basically. So these IO streams, what are these IO streams? So IO streams are nothing but kind of input out. We call them as input output streams, and these inputs output streams they have 4 base classes. Okay, the classification of these IO streams into those 4 types of streams, input output streams, is based on 2 criterias. Okay, one is the direction of the, so one is a direction, right, whether it's for input or for output. Okay, something which is to be used for input, what is for or based fine. So we have classes, IO stream classes, which are for input purpose, and we have IO stream classes which are for the output purpose. So input output, that's a direction of the stream, okay, and other is the kind of data. Now when we say data, whether the data happens to be text data which you would like to process, or you would like to process the binary data, okay, text or binary. When we say so that's a kind of data, fine, with for the IO stream. So IO stream classes is going to be like this. Okay, I'll first give the names of those 4 top level base classes for the input output purpose in the java.io package. Okay, so what we are looking at is the java.io package and 4 top level classes here. Okay, so we can categorize like this. Okay, so one is, okay, let's say, so this is one is for input purpose. So this is the direction, okay, input purpose, other is for the output purpose. Okay, so that's one criteria. And another criteria is whether it is for binary data, okay, or it is for text data. Good morning. So that way we have four things here. Okay, so the 4 classes, right? So if it's the binary and for input purpose, we call it as the, we have a class called the input stream. Okay, it's binary for output, yes, we'll call it as the output stream. Okay, and if it's for input and if it's a text data we are dealing with, fine, then we should be using what we call as a reader, and we have the writer. Okay, so for input output, fine, these are the 4 top level IO stream classes. Okay, fine. So this is what basically, so if I look at the java.io package, what I'll find is these 4 classes are there, and the other classes, most of the other classes are nothing but some subclass of these classes. Fine, so it's basically we categorize them into 4 types of IO stream classes. Okay, fine. Binary for the purpose of input, binary for the purpose of output. See, it's we call it as direction, right? So see, from the direction point of view, what is input output? So it's like, if this is an object of the type input stream or a reader, right, then it enables you to fetch data from this object. So object will be of the type input stream or a reader, and then what you should be doing is you should be able to fetch data from that object. Okay, that means what these objects will have, these objects in turn will have some kind of a source from where the data will be made available. Okay, they need a source. Okay, fine. So what they give to you is either, so if it's a binary data we are talking about, when I say binary data, right, binary means we are talking in terms of bytes, whereas when we say it's a text data, we are talking in terms of the type char, the string type, the char type. So that's going to be used for the text data. Okay, and so the direction is this object, if you have this object, right, of the type input stream or a reader, you will be able to fetch the data. And the basic method, the method name anyway, is quite easy to guess. The method name would be, the basic method name would be about read method. And it's a read method. It's a read. So what read has to return some data, or we'll see how the read method overloading is done. So that, right? So we'll see. It's about fetching data from some source. Okay. Whereas an output stream, okay, if there is an object of output stream or a writer, fine, then it's an object where you should be able to push data into it. you give the data to it. Okay, so if you push or okay, the method here which is used here is the method called, the basic method is the write method. Okay, so with the help of write, see what is the write method is accordingly different according to the type of stream it is. If it's a binary stream, the write methods are used for sending bytes into it. So you can send bytes because it's a binary data. Fine, it's a binary stream. It's a text string, that means it's a writer. Okay, then you should be able to put text into it, and you won't be able to push bytes into it. You will be only allowed to put text data. Okay, and these output related, when we say this is output related IO stream, they would have some kind of a sink. Okay, so this has a source and this has a sink. Okay, so whatever you write, what will happen to that? Oh, it has to reach some destination. When they have some kind of a sink, right, where the thing, that sink could be a file, physical file. So you could be putting data into a file. Fine, but it's not only about file. Okay, input output is not only about file. Okay, you could be writing to the network. Fine, you could be reading from the network, writing to the network. Okay, fine. So it's not about only files that we are dealing with. Of course, most commonly input output is from some kind of a device, okay, or some file. File objects are used for representing even devices also, right? Devices also represented with the help of file. Okay, fine. So this is fine. Okay, so when clear IO stream, the concept, 4 top level stream classes. Names of those classes are input stream, output stream for binary data, and reader and writer for the text data. Okay, fine. There are some classes. See, whenever we create any of these objects of IO stream classes, they will use some kind of a system resources. Okay, fine. So they have some common interface. I'll put one interface name which is common across all the 4. So there is an interface implemented by all the 4 classes. There is an interface called closable. Okay, implemented by all 4 of them. Okay, fine. What is closable? Oh, it extends from that interface called auto closable. And you have the close method in auto closable. Okay, and so this is the one with the close method. Fine. So all of them, all these classes, they have a close method. All the IO stream classes have a close method. Okay, then what are the other things in this java.io package basically? And so java.io package, one thing is these 4 classes and lot of subclasses of each of those. Okay, other than this, yes, we see one interface like closable, which is to be implemented by, which has been implemented by all these IO streams. Okay, so these 4, when they are implementing the closable, something common for the writer side. Okay, output side. For the output side, we have another interface. So in the output side, sorry. Right. So for the output side, yes, we have an interface called, which is implemented by these. That's an interface called flushable. So there is one interface called flushable in the java.io package. Fine. And this has a method called flush. Okay, we have a flush method in the flushable interface. So flushable is for output side. Okay, and how it is working is something like this. Okay, see, if you have some object which is a output stream or a writer object. Okay, yeah, fine. Sorry, I put it on the wrong side. Yeah, flush is for this. Okay, so if you have the output stream or the writer object, okay, Fine. Then how flush is going to work is something like this, right? When we use okay. So if let's assume this is a object of output stream or a writer, okay, that means we can write into it. When we are writing, we are giving data to it, right? So we have a method called write, right, which is used for giving data. And what this will have, it has a sink. So let's say if the sink is a file here, right, so it is going to write into the file on the file system. Whatever data we give, it's supposed to put it into the file in the file system. But now or it could be any other device also, some final destination is there for this output stream. Okay, so now for the purpose of efficiency, and it may not be good to write one byte each time someone gives you 1 byte to be returned to a file and you just put it straight away into the file. That may not be so efficient. Okay, so what these output stream or a writer may be doing is they are free to use some kind of a buffer. So internally they will keep a buffer. Fine. So whenever we write, your write method doesn't have to wait for that thing to go to the final destination. Fine. Output stream and writer, they have a destination. Okay, so it's not necessary that they reach the destination, that data must reach the destination. Okay, so when you write, yes, it will be taking it into a buffer, and once the buffer is full, yes, then it will use it will send it to the final destination. Okay, so it uses some kind of a buffer. Output side is free to use buffers. Okay, so implementation of output stream or a writer would be using a buffer. Okay, fine. So we have this flush method with the idea that yes, if someone says flush, okay, then it ensures that whatever you had it has got in the buffer has reached the destination. There's nothing remaining pending in the buffer. Okay, everything whatever was there, fine, not yet sent to that final destination. Calling flush, yes, it will have to wait till everything reaches the destination. And so if flush has finished, that means you are sure there's nothing remaining, it has gone to the destination. And so that's the idea of flush method. Right? So we have this flushable interface. Okay, fine. Yeah, so for the output side, yes, we have the flushable interface. Closable for all four. Fine, for all four kinds of streams, we have the closable. For output side, we have the flushable. Okay, so flush method would be there. Fine. Yeah. Okay. Fine. Now, other than the stream classes, right? So other than the stream classes, we have still okay. So fine. There are many. See, there are many interfaces and classes here. So other than the stream, what are the other kind of classes which we have here? And so some more classes which are available in the java.io package. Okay, one is a class called file. Okay, fine. This is a class which represents an abstract path in the file system. Fine, representing a abstract path in the file system. Fine. So this we'll be discussing today itself. Okay. Fine. Other than this, yes, we have certain interfaces. Okay, especially for the binary output. Fine. We have the base class called output stream, and for input we have a base class called input stream. Fine. For the binary data we have these classes, right? Input stream and the output stream. Okay, so we have input stream for reading purpose. Fine. The input stream class has only very basic elementary methods for fetching bytes from a source. Okay, input stream has very elementary basic read methods. Okay, fine. But we know which are the binary types for us. We have the byte, short, int, long, float, double, fine, or even the Boolean type. So we have our primitive types, right? So your interest may be to fetch data of that type from the bytes which are available in the source. So if there are 4 bytes in the source, someone wants to read it as an int value, right? Not the 4 different bytes. So when we find the basic method which we have in the input stream would be reading it one byte. Will give you byte by byte. Okay, so every byte is different for it, right? But yes, you may be interested in, okay, let me have it as a int value. Or there are 8 bytes, let me have it as a long value. Or no, those 4 bytes should be read as a float value. Okay, when you want to construct a float from it, right? So for this kind of purpose, yes, we need more API, right? We need some more additional methods, and therefore we have a few interfaces, right? Because this kind of activity, reading or writing, is needed in both direction, right? It would be reading as well as writing. So we have these interfaces called data input and the data output. Okay. And so these would handle the binary types. Okay, these are used for handling the input output related to the binary type, but represented in the form of interfaces. So we have these interfaces called data input and data output. So they can handle most of all the primitive types. Fine. Okay, fine. And so these are so interfaces, they would have method, right, for reading as well. So this would have methods for reading, that's here, fine, reading methods. This would have methods for writing purpose. Fine. So now this is fine, but then in Java, it's not only about, Java is an object-oriented language, right? So it's more about objects. It's not only about primitive types. Data input, data output, they can handle primitive types. Okay, but if you want to do handling of some kind of persisting an object, saving an object, okay, or recreating an object from a set of bytes, okay, there is an object to save it in a manner such that someone can recreate an object from those bytes. Okay, fine. So for such purpose, we have some additional methods. They are not part of the data input or data output. So we have extension of data input interface called object input. Okay, and same way we have something called object output. So those would be used for dealing with, fine. One is about saving the state of the object. Okay, whatever is the current state of the object, I would like to save it somewhere, or convert them. Basic idea would be convert them into a bytes and put it in some kind of a destination sink. So object output would be used for persisting or storing an object, state of the object, and those bytes which are generated by the object output, right? So, fine. Someone can recreate the object in the same state by using the methods of object input. So object input methods, they are helpful for creating a new object. See, understand how object can be created. We have normally been creating it with the help of constructor, using new, right, and create an object. There's one more way which we have seen, but we haven't used it much. Yeah. Another way is calling the clone method. Okay, fine. clone method, but it requires that the type should be clonable. Okay, and another way here is using a method of object input. And we have some method called read object. So that would create a new object for us. Okay, but for creating that object, yes, first some object should have been saved. It's right. Okay, if it's there, if something was, some object was which was existing in memory and was saved in some particular state, so that recreating the same state for an object and create object in the same state.
That is clone.
No, that's not cloning. Clone was, we had seen clone is a method of the object class. Any object, when you call the clone method, it should create a copy. Clone is copy. Okay, it's within the memory. Right? See, clone is like you have some object which is of a class, but one requirement was that class, the object should be of a class which implements clonable. Okay, now if you call the clone method on it, okay, what it does, it creates a copy of that object. Right? It creates a copy of that object. Right? So I say, okay, this is clone. Okay, so this is a copy of that object. So if this object, whatever the instance variables which were there here, right, those things, a copy of that is created from in another object. So it's a different object. So that's fine. Okay, a new object has been allocated in this case, but we didn't use a constructor for that. Right? Okay. Now coming to, okay, how is it, what we are saying, read object is also creating a copy, right? But it's something different in the sense that here is an object. Okay. When here is some object, it has some instance variable. There's a state of the instance variables. Right? What we are doing is we are asking it to convert it into a series of bytes. Fine, converting it into a series of bytes, giving it to some kind of an output stream. Okay, what is the output stream having? It is having a destination. Okay, as an example, one possible destination is a file in the file system. So here is a file in the file system, and what we have done, the bytes have gone into a file. Okay, those bytes have been written into a file. Right? What it has stored? It has stored sufficient information for those bytes. The bytes which have been stored have to be such that if someone says, okay, using a object input, right? If someone uses an object input and says, okay, I would like to have my source from that same file, those bytes which were written earlier, fine, they must be having sufficient information for it to be able to recreate the copy of that. Now see, there is a persistence which can be done in this case, right? Because you have written it into a file, even if you exit, those bytes stay there. Your Java virtual machine has terminated, you have come out of your fine, and then, okay, now I restart my application and say, oh, whatever I have saved last time, that same object, I want it in the same state. I want to recreate it. And some updates which were done on that object, yeah, I want them to be recreated and to be using it. So that's where you will be recreating the object. Okay, and yes, in our exercise, yes, this is what we will also be doing. And where we will need this, let me show it already. See, we have done the bank clerk thing, right? Okay, so bank clerk was taking commands. It was populating the bank object with the accounts. We said open account, and yes, it created those account objects. Current account, savings account objects were being created. So in the object of bank, there are so many other objects, right? Within the bank object, there are the account objects. Account objects in turn have the transaction objects, right? So all that object, the entire object of bank, I can say, okay, let me push it into a file. Let me push it into a file. When I exit, when I say quit and I am coming out of the application, right? And restart next time, I can have those accounts available to me if I read from that place where I had saved it. See, clone is in the session of the JVM itself. Getting the point? It's creating a copy, but you are in the same session, right? It's in your current JVM session. Okay, but you have another JVM, right? See, it could even, just think in another way. A clone is within one virtual machine, whereas it could be like this. You have your one virtual machine, okay? There is an object which you are pushing. Maybe it's not going into a file, but it is going to some other virtual machine where there is a input, okay? And some object which is here is made available in the other virtual machine. Here is the object output, writing an object, and here is object input, reading the object to create it. See, input output is not in file only, right? Even in networking, yes, we have the input output, and it could be across a network. Yeah, so we have the fine. So some of the useful interfaces, data input, data output, they are also fine. They are good, but they are good with the primitive types, and they also deal with text also. And data input, data output, they will be dealing with text also. It's not only the primitive types. Okay, they can deal with the string type, right? Reading and writing a string data. Okay, so that can be done, taken care with data input, data output. But object input, object output is for other kinds of objects, any kind of object. No, not just any kind of object, because it could be dangerous for someone to allow any kind of object to be put into a sequence of bytes and be persisted, right? So that cannot be allowed for everything, right? So we have another interface here, okay? Just like we had the clonable interface for the clone to work, right? Same way, see this process of converting an object into a sequence of bytes, right? Which are useful for it to be able to recreate the object. Okay, that process of converting an object into a sequence of bytes, we call it as serializing the object. So we are serializing the object. Okay, so we cannot serialize just any kind of objects. Fine. So this, I was saying, oh, we have this state of the object being put into a sequence of bytes. Right? So this is permissible by the class implementing the interface called serializable. Okay, so in the java.io package, there is an interface called serializable. And so one of the interfaces available in the, just like we had that interface called clonable for the clone to work, right? Same way, for the method, there is actually a method named as write object. And that's a method of the object output. So object output has a method called write object. For that to work, it must be serializable. The first requirement is serializable. When there are more detailed things which will come to later, and there are, it's not just, okay, just mark anything serializable and it should work. No, it's not going to work with every object. Okay, because what is serialization, what is involved in that, fine, we'll have to see that also. Okay, and we'll come to that also later. Okay, but the idea is clear that we have this input stream, output stream, those four classes, right? And then we have the related interfaces. We have seen some of those. Okay. To deal with the file in the file, to represent a path in the file system, we have a class called the file class. Okay. And then we were looking at some interfaces like this. Okay. Data input, data output, fine, for primitives, and object input, object output for the objects, and reference type basically. Okay. Just a small note here related to serializable. All array types are serializable. Okay. All arrays are clonable and serializable both. So if there is any array type, you can just call the clone method. Fine. Okay. And if you want to use it for serialization, yes, it can be serialized. Okay. Fine. Okay. So some more classes. Now we have this data input, data output, which deal with the primitives, right? We have input stream, output stream, reader, and writer. They are classes. They are not interfaces. Data input, data output, they are interfaces. Okay. So now, if I look at a file in the file system, right, it's you can do reading from a file. We can open a file for reading, right, and do reading from a file. So yes, we would have an input stream for that purpose. If you want to read from a file, you would have some kind of an input stream which can read from a file. If you want to write to a file, you would use a class, subclass, which is a subclass of the output stream. Some subclass of output stream will be used for writing data to a file. But I would like to do both of them. I would like to open a file for reading as well as for writing. Right? Open a file once and be able to read and write, do both the operations on it. Okay. So for that purpose, we have another class here, which is basic. It's not under the input stream, output stream, reader or writer, because we know there is single inheritance of classes in Java. Okay. So to achieve that, yes, we have taking the help of interfaces. So we have a class called random access file. Oops. We have this class called the random access file. Okay. This class is implementing these two interfaces. This one and this one. They're both implemented by the random access file. So a class with methods for reading as well as for writing. Right? And it handles all primitives plus the text. Okay. When I say text, here we mean strings here. Okay, strings can be handled. Input output of a string, reading writing string basically, and into a file. And so only for file, right? So this is for file. We have the class called random access file. Okay. A few more interfaces. Yeah, they're more closer to the class called file. Okay, so for the class called file, right, related to that, a few interfaces here. See, someone wants to do, when we talk of file, okay, a file object would represent a physical file or a directory. Even directory is treated like a file. Okay? So when you look at a directory, what does a directory have? it has a list of files again, right? A directory has a list of files, and a directory is also a file for us. Okay, fine. So you would like to ask for a list of files, right? Fine. If there is a directory, you like to get a list of files. But do you want the entire list of files, or something like, oh, let me apply a predicate and then get the things? Okay. Of course, we don't have this interface which I'm talking about is a pre java.util.function package. It's been there right from the beginning, but the concept of predicate is there. That's why. So we have methods to return a Boolean value. Okay, so we have these interfaces, and so these are so we have a couple of interfaces. There's an interface called file name filter, and another interface called the file filter. So we have these interfaces called file name filter and file filter. The idea here is, given a file, a path to a file, it should be able to say yes or no, return a true value, whether it's acceptable or not, working like a predicate. And so these would work like a predicate for us. Okay, so certain methods in the file, yes, they will be taking the help of these interfaces. Okay, and so this is an overview of what is there in the java.io package. Yeah, it's mainly full of the stream, 4 top level stream classes which we saw: input stream, output stream, reader, writer. Oh, they have so many subclasses. Okay, fine. So fine, we'll look at all of those subclasses. Fine, but before that, let's first start with the class called file. So we start with the class called. Okay, we look at this.